Welcome everyone, my name is Agustin and I would like to introduce you my poster presentation entitled Machine Learning Models for Prediction of Cardiovascular Disease Mortality using Demographics, Dietary Features and Blood Biomarkers. This is the introduction. Cardiovascular disease remains a significant global health challenge. Nutrition is a key factor in the onset and progression of cardiovascular disease, highlighting the importance of integrating dietary data into risk assessment models. However, the complexity of dietary data poses a challenge. This is where machine learning comes into play. Machine learning's capability to analyze multifaceted data makes it an invaluable tool in this context. We leverage comprehensive databases such as the National Health and Nutrition Examination Survey, known as NHANES, to enhance cardiovascular disease risk prediction and foster individualized prevention strategies. In our study, we developed machine learning models that utilize health and nutritional metrics to predict cardiovascular disease mortality. Our approach includes evaluation metrics, strategic feature selection, class balancing, and the use of Shapley additive explanation, known as SHAP, values to pinpoint critical risk factors. This is the flowchart of our study. Our dataset comprised 50,912 participants from the NHANES database, spanning the years 2003 to 2012. Participants provided detailed health and dietary information along with health examination variables. We excluded participants under 20, those with a history of cardiovascular disease, incomplete dietary data, or extreme daily caloric intake. This refined our study population to 9,706. We employed an undersampling strategy to balance the dataset. It was then randomly divided into a training set, 80%, and a test set of 20%. Variables with more than 30% missing data were excluded from the study. For the nutrition model, 33 variables were chosen, while the health model comprised 26 variables, including demographic, general health, and blood biomarkers. The mixed model incorporated all selected variables. We chose 5 machine learning models for our analysis: logistic regression, support vector machine, random forest, XGBoost, and light GBM. Their performance was assessed using metrics like area under the curve, accuracy, recall, precision, and F1 score. To understand the influence of each variable, we used SHAP values. This method helped identify key factors contributing to cardiovascular risk in our models. Here we have the first section of the results. Table 1 outlines variables that were found significant when comparing cardiovascular disease death with the control group, using traditional methods. As expected, those who died from cardiovascular disease were typically older, more often male, had higher BMI, and altered blood biomarkers such as glycohemoglobin. In Table 2, we examine the efficacy of the machine learning algorithms for the health, nutrition, and mixed models. Notably, the random forest algorithm excelled in all 3 categories. When comparing the 3 models, we can see that the mixed model outperformed the other 2, followed by the health model and finally the nutrition model. The reason for this can be the stronger predictive capabilities of health variables or the limited data points from the enhanced dataset for nutritional variables. However, the mixed model higher performance underscores the value of integrating dietary information into predictive models. In here we can see mean absolute SHAP values on top row and the relationship between variable and death outcome on the bottom row for the top 10 variables in each model. Age was found to be the most important variable overall. Most of the other important health variables have been already studied as significant for cardiovascular disease development, like blood pressure, smoking status, or glycated hemoglobin. Regarding the impact of dietary variables, our study established that the intakes of fiber, calcium, magnesium, polyunsaturated fatty acid, vitamin E, vitamin B6, protein, vitamin B2, potassium, and sodium were significant features of the machine learning models. In the discussion section, we summarize the main important variables in our study and highlight the superior performance of the random forest algorithm in this context. Although the nutrition model had a lesser predictive power, the nutritional data enhanced the machine learning model's efficiency. The key nutritional factors in the mixed model included fiber and vitamin E intake. In conclusion, our study illustrates the potential role of nutritional data in prediction of cardiovascular disease mortality using machine-based approaches, and accentuate the potential of machine learning and artificial intelligence methodologies in the realm of nutritional epidemiology. Finally, I would like to show you the full view of our poster. Thank you very much for your attention.